Good morning, everyone, and welcome to the final virtual conference of the Food-Factory-4-Us International Student Competition. This is the 2019 edition, which is focused on fighting food, energy, and water losses in the food chain. We have a very exciting program today with teams of students from around the world presenting their projects. With that, I turn it over to the organizer of the Food-Factory-4-Us competition and the president of the ISEKI-Food Association Executive Board, and that is Paola Picchia. Paola, I will make you presenter.
Okay, thank you very much, Catherine, for this introduction. And I have my presentation, a very short introduction. Can you see it?
Yes.
Now I move to the presentation mode. And if any issue, just let me know. We are at the last step of the Food-Factory-4-Us 2019 edition, and this is the outline of today. Actually, we have an intense morning to stay together, and each of the team will have the opportunity to see the projects presented so far. Actually, out of the 15 teams that we had at the beginning, only 5 managed to submit the final report and the PowerPoint presentation of the project itself. At the end of the morning, we will have a break because actually we need to finalize the evaluation that has already started. I thank at first the ISEKI-Food Association, and which is the main sponsor of this competition this year, along with the post-harvest project and Elsevier as endorser. ISEKI-Food Association is an international non-profit organization with aimed at networking universities, research center, industries, and any other stakeholder of the food sector to promote the development, improvement of the higher education in food studies, but also promote synergies in all the food chain. Actually, during the main aims are here reported, the quality improvement of higher education and bridging education with research. In this respect, the ISEKI-Food Association is organizing a series of activities, including the conference and also a series of other tools that could help us and you as also students to get in touch with the other main stakeholders of the food sector. The ISEKI-Food Association was founded in 2005. After a series of projects and within a series of Erasmus thematic network called ISEKI, and the ISEKI-Food Association was born with the aim to sustain these the activities and the products of all these projects. So far, the ISEKI-Food Association is promoting also different projects and activities within within other Erasmus projects, but also Horizon 2020 and other international frameworks. In this respect, the ISEKI-Food Association is more than almost 20 years working in the food sector, and we have partners both as individual members and universities and institutional members from all over the world. Within these projects in which ISEKI-Food Association was involved or promoter, we have been working within the FooD-STA Erasmus Knowledge Alliance with aim to promote the setting of a virtual platform to make a close interaction between academia and industry called FooD-STA centers. And within these projects also we design and set this international competition, which is based on virtual activities, let's say, trying to virtually connect students teams from all over the world with the aim to improve both the practical knowledge and abilities of you as a student, but also to promote the attention also to industry-based or industry-based or issues that we have currently in the food sector to favor the interaction between students and also companies and universities all over the world. And we hope to have achieved somehow all these aims. This Food-Factory-4-Us started in 2017, and now we are at the third edition. And each edition has had a specific theme that was set within a scientific committee. And this year, the theme was fighting food, energy, and water losses. The scientific and organizing team is made, besides myself, also of Florence Dubois-Brissonnet from AgroParisTech, Cristina Silva from the Catholic University of Portugal, Gerhard Schleining from Broku, Christophe Cotillon, and Catherine Flynn. Most of them are also members of the board of the ISEKI-Food Association. The activities that we asked you as a team registered to this competition is to implement and design ideas, tools, and actions to promote and to try to solve somehow the issues that was the main theme suggested for the specific edition. Not a practice to this aim, we didn't ask you necessarily to develop practical work in the lab, but it can be also simply the suggestion of ideas that obviously will need an additional commitment, but also support maybe from other stakeholders or from other, also from the, let's say, financial point of view. The Food-Factory-4-Us had somehow this main step, besides the registration and the main acceptance. Then we had a series of, at a time in which you as a team have been working on your project, and during this time we organize some training, webinars, and activities that could be helping you in finalizing your project. Actually, now we are at the last step of this diagram. And we, at the end of this morning, we will announce the winners of the competition. To this aim, you have been asked to submit a report and a PowerPoint presentation. And at the same time, besides this, we will evaluate your presentation of today, along with also your ability to answer questions. And here are the main criteria that have been taken into account already for your report and the PowerPoint presentation, and we will evaluate also the presentation itself. Each of the participants that submitted the report and the PowerPoint presentation will receive a certificate, and obviously the winners also the final certificate as winners, besides the award that obviously has a different entity. In this case, we have some money, different entity depending on the ranking in the first 3 positions. These are just the titles of the trainings that we carried out, and now we start with the last part, which is not the last part of the day, but is the first and the more important one, because is your time. They are teams, and here are the 5 ones that, let's say, survived after this 6 months time of the competition. And we will follow obviously the timing that we have fixed in the initial program. So for me now, I could conclude my presentation here, and I would like to give the word again to Catherine Flynn to start the presentation of the report. I would like to thank at first Gerhard Schleining, Christina Silva, and Christophe Cotillon, which are here, and they are actually part of the evaluation team of this morning. Thank you very much for the time that you are dedicating also to this competition. So, Catherine, the floor is yours now.
Thanks, Paola. Thanks very much. So with that, I would like to introduce the first team. And the first team is called the Cyclos team, and they are presenting a project called Biodegradable Cups Made of Brewers' Spent Grain, or GrainGain cups. And Ireneos will be leading the team presentation. And with that, Ireneos, I will make you the presenter. And you should be able to now share your webcam and also share your screen. There you go. Great. Ireneos, it is all yours. Can you turn on your webcam, Ireneos?
Good.
So can you see my presentation?
Yes, everything is great.
Okay. So good morning, everyone, or good afternoon. Ireneos Georgiou, I'm from Cyprus. Today I'm going to present you our project with my team called Cyclos. Unfortunately, my other 2 colleagues are having their internship, so they are working today. So I'm going to present you alone our project. So our project is called GrainGain Cups and concerns the development of biodegradable cups made from a byproduct of beer. In order to introduce you a bit into the topic, few words about beer. Beer is the most broadly consumed alcoholic beverage in the globe and the 3rd most popular drink after water and tea. Here we can see that the production of beer is increasing in the last years, as in 2017 we had beer production of approximately 200 billion liters. The main ingredient after water that is used in beer is barley. After beer production, this barley results to the product that is called Brewers' Spent Grain, or BSG. This byproduct covers the 85% of the beer waste, and the problem with this byproduct is it doesn't go easily, it doesn't degrade easily. So when it's heaped into the environment, it undergoes anaerobic fermentation and produces methane, which which affects the environment. Therefore, different ways are found and are existed for utilizing BSG. The most common and conventional way is for feedstock. However, often these huge amounts of PSG, overcome the amounts that are needed for the breeders. Moreover, some animals like pigs cannot digest BSG, therefore after they excrete it, methane is again produced. More recent ways of utilizing PSG is as a nutrient supplier for mushroom production, as a wood alternative for paper production, and most recently as edible packaging. Here we may observe the fibers containing PSG, which are in great amounts, more than 70%. Therefore, this gives us the potential of for other uses of PSG. So we, as GrainGain, we thought of developing the idea of biodegradable cups in such a way to promote a sustainable product and throughout its production to reduce waste, water, and energy. Can you hear me well, by the way?
Yes, just fine.
Okay. So how the idea was generated was when we were wondered how many microbreweries in Greece, how many microbreweries exist in Greece where I was studying. So in 2009 there were 6 microbreweries, and we found out that today, 10 years after, this amount was also 10 times larger. So today we have approximately 60 microbreweries. Here we may observe an indicative map of the microbreweries in Greece from some years ago. So we asked, we wanted to see how they utilize these microbreweries, how they utilize PSG. So we contacted them and got an answer from 21 of them. We asked them how many tons of barley do they use per year, how they utilize PSG, and if they have any gain from utilizing it. So we found out that most of them give it for animal feed, and that none of them have a gain from utilizing it, whereas some also have a loss because they get charged for the transportation costs to take the PSG to the breeders. Moreover, by contacting them, we found out that in many cases some amounts of PSG remain unutilized, therefore they are heaped into the environment because these amounts are huge, therefore the breeders sometimes do not need so large quantities. For the production of GrainGain cups, we thought of obtaining PSG via short distance logistics, which means that we would obtain the PSG from the microbreweries that are within 3 hours distance from the industry, hypothetically located in Thessaloniki, the second largest city of Greece. In this way, we would reduce the CO2 emissions and also the transportation costs. As the PSG will be obtained without a cost, the industry will only have the indirect costs, including energy and water. However, we know that PSG is sensitive as it can undergo anaerobic fermentation some days after the collection. Therefore, we found a patented method for drying specifically PSG. So in this way, we would extend the shelf life and we would reduce the storage cost and the waste. This process, this patented method, consists of 2 phases. In the first phase, there is a mechanical pressing for the moisture of PSG to be lowered by 70%. And then the liquid that is obtained, we thought, apart from the method, apart from the patented method, we thought by ourselves to treat this wastewater via ultrafiltration membranes and use it for cleaning purposes at the factory. In the second phase, the solids that are obtained undergo a thermal drying, and they are transported through hot air and then by an air current at room temperature. So we result with a product with 15 or less % of moisture. In order to lower the process costs, we thought of using also the BSG for biofuel production. This may be achieved via anaerobic digester and Saccharomyces cerevisiae. And to our knowledge, we know that 2 microbreweries currently are using this way. So we know that it is achievable. So by using BSG for biofuel production, we would supply our industry with energy, with its own energy. We would lower the energy costs and higher BSG will be utilized. So we know that BSG is rich in fibers and cellulose, so we would extract this for the caps development. However, we know also that cellulose has a costly degradation as it needs acid hydrolysis and high pressure. Moreover, we expect that opacity will be appeared in the product, which will cause some barriers to its characteristics. Therefore, we thought of using cellulases. These enzymes can catalyze the degradation, therefore they will decrease the costs, and also they may improve the transparency as these enzymes are already used for clarification of beers and juices. In order to conclude, we know that currently bio-based plastic production is expensive, but as Dr. Birgiovanni said the other time, this cost will be significantly reduced thanks to the new technologies that will be soon available. We as GrainGain, we also add by reducing waste, it means that we increase profit. Therefore, we have a reason why to use waste and introduce new products. Also, we would like to get rid of the old quote of for the life of plastics and introduce the life of bioplastics, produced in 5 seconds, used for 5 minutes, and broken down not in 500 years, but within few weeks. Thank you very much for your attention. That was a brief presentation for our project with the time we had. Hope you liked it, and any questions are welcome.
Thank you, Irinios. That was very, very nice. We open the floor now to questions. You can raise your hand if you are an attendee, and I can open your microphone, or you can type a question and I can read it to Irinios. If you are on the scientific board, you can open your own microphone and ask a question.
I have one question.
Sorry.
Christoph, go ahead.
No, my question is about, of course, the food packaging that you can produce with this waste from beer. But did you really obtain this packaging, bio-packaging, or not at the moment? Is it only plants for you, or is it really concrete?
It's only theory at the moment, because there was sufficient time to try, and also the machinery are not able to be obtained. I have personally developed edible films, so I have an idea on edible packaging and biodegradable packaging, but the specific product was only as a plan, not applied.
Okay, thank you.
May I ask a question? Thank you very much for a very nice presentation, and I very much appreciate this idea. Just a question about the production, because I was also working some years ago on using sugar beet waste for injection molded products. We faced some problems with the water sensitivity and also with the also the machinery. It sticks to the machinery. So do you have already some experiences on that production?
Definitely the machinability, as we call, is a completely different level. I mean, also for my dissertation that I developed these edible films, it is completely different to apply it in an industrial level. So definitely much research is needed on it. I don't know specifically for industrial scale production what can be achieved for avoiding such problems. But I know that definitely the idea is different than when you apply it. I mean, in an industrial level scale. Did I cover your question?
Yeah, thank you.
Thank you.
Okay.
I have one question, which is related to one sentence of your presentation. You say that the fact that it's not transparent and I mean, it's not. It's not typical for the usage, the current usage, or the common biodegradable plastics, so white or transparent. But don't you think that the consumers nowadays may also be ready for products that may have different properties if they connect these properties to a sustainable recovery of byproducts?
I know what you mean, and actually I had the same thought. I had this discussion the other day with my professor that it's also a matter of marketing nowadays for the more sustainable products to be with a brown color, let's say. However, let's say if clarification is achieved, definitely you also reach a wider consumer, a more wide consumer population, let's say. I mean, also for people that are not aware of sustainability. If the cups are clarified, if they are transparent, they will attract them also. But definitely we know that, yes, with sustainable products, with biodegradable products, we would have some disadvantages in clarification and these things, but do not necessarily affect us do not necessarily affect the functional properties of the product.
Thank you.
Thank you.
Great. Thank you, Ireneos. Thank you, and for all of the questions also. And
Christina.
May I make a question? Sorry. Yeah. Also, thank you for your presentation. I was also surprised that the patent, if I'm not wrong, from Portugal, right?
Yes, biodegradable. Yeah.
Okay, so I'm from Portugal. I was not aware. Anyway, my question is also in line with the one of Paola's. Recently, very recent, because I have a colleague from packaging and she's also expert in EFSA. And she told me, for example, paper cups that at least as a normal consumer, I would think is better than plastic for environment. She said, no way, it's as bad as plastic, because the cover that these paper cups have, this is very bad for the environment for recycling it. So my question is, are you aware of environmental impact of recycling these cups utilizing the byproduct?
So this product is not only recyclable, but it can be degraded in the environment when you throw it with your conventional waste. The problem with the recycling is that yeah, many products cannot be recycled due to multiple layers they have, and also due to microbial, let's say, danger. So we target on biodegradable, compostable, and edible packaging for the reason that recycling doesn't seem to be so efficient nowadays. So we are targeting on this, if you understand me. I mean, we are not targeting on recycling, but on biodegradable.
Thank you very much.
Thank you.
And the problem is that if just I can add something, more you add functionality to your packaging, and less it is biodegradable. Even if you are starting from bio-based material, if you add functionalities to preserve the food inside, it's less biodegradable.
Okay. Could you like elaborate a bit more on this topic? I mean, just for interest, to explain once again this.
I don't know if it's if we have time to do that, but when you, for instance, when you want to preserve your food, you had coatings, or you had special coatings for breathing, for the exchange of gases, with and more you had these functionalities to the bio-based initial packaging. The biodegradability will be more and more difficult to be assumed. Okay, but we can discuss about that later on in another.
I understand what you said. Yes, thank you.
Okay, so we move now to the second team, and that is Team Food Savers. And their project is entitled Sesame Hull for Production of Functional Ice Cream. And with that, I will turn the presenter over to Yusa, and you can turn on your webcam, please, and share your slides. Great, excellent, Yusa. Can you, good. Okay, so it is all yours.
Yes, okay. Okay. Good morning, everyone. Here we are, the Food Savers, and we are going to talk about the utilization of Sesame Hull for production of functional ice cream. Here is our team. My name is Muhammad Yasser, and my colleague Mirtal Ayman and Yusra Saber, and she will be presenting with me the presentation. Here's our content. Okay, first of all, let me talk about the little thing, which is the food wastes or byproducts, which mainly refers to the edible food products, which are intended for the purpose of human consumption, that they are either to be discarded or consumed by pests or as animal feed. Some of the food industries are disposing their valuable wastes and doesn't get any benefits from them. But other industries are reprocessing their wastes and use them as functional ingredients in another foods to have more market share in the market. And as we can see, here is some of the crops seeds, which the sesame is one of them. So now we are going to talk about the sesame. Sesame is a crop which is mainly used in Egypt and the Middle East mainly. The sesame seeds the sesame seed hulls are representing from 12 to 17% of the sesame seed weight, which means in 1,000 kilogram of sesame seeds, the sesame hull is representing from 120 to 170 kilogram. So it's a huge waste. So as a topping. Can you hear me?
Yes, you came back.
Yes, okay, you can hear me now?
Yes.
Okay, let me get back. As you see here, the whole sesame seed in the picture, it's used on the surface of bakery products or as a part of salads or a dressing for some foods. And the hulled sesame seeds are used mainly in the production of tahini, which is mainly Eastern Mediterranean and Middle Eastern food. But regarding to its high nutritional value, as shown below, it contains calcium, oxalic acid, minerals, and crude fibers, and it's very rich in crude fibers. So it can be used as a functional ingredient to produce high nutritional value products, which are we're going to talk about it in ice cream. So first, let me tell you the aim of our investigation. It's all about the utilization of sesame hull as a food plant waste in ice cream production. Okay, the utilization of the maximum percentage of sesame hull used as an ingredient in ice cream formulation for the production of healthy food with reduction in the cost. Also to investigate the effects of using the sesame hull in ice cream formulation on the chemical and physical properties of the resultant ice cream. And here is the most important part, which we are targeting some segments that can't afford the high cost ice cream. And regarding to a cost, a 12 to 15% reduction in cost was estimated by substituting substituting the milk powder by the sesame hull. And as we see, sesame hull can be used to substitute some of the ingredients of ice cream formula to produce low-cost ice cream with higher nutritional value. As we said, that we substituted the milk powder in the ice cream formula with the sesame hull, grounded sesame hull. Okay, now Yusra will continue with you.
Okay, so now let's get to the base of our product, which is the ice cream. Well, you all know that the ice cream, this is something delicious that we all, that neither of us can actually, this is something so delicious that neither of us can resist its taste in general. So this is basically made from milk, from either dairy milk or cream or coconut or almond milk or other sources of milk. And the other ingredients include like water, sugar, whole milk powder, cream, and there's also the blend of emulsions and stabilizers, and also there's the colors and the flavoring agent that gives it its tasty, or that makes it a tasty food. And now let's get to the ice cream components. First, we have the two halves here in this picture. We have 50% of it of the ice cream is composed of air, which gives it the volume of the ice cream, and we have the other 50%, which gives it the mass of the ice cream, which is composed of all these ingredients. We have here first the water. The water in the ice cream. This is a liquid that aids it to form the ice crystals, and we have also the fat in it. So the fat incorporates in the air holding into the ice cream, and also it gives it its creaminess and its smooth texture. We have also the milk solid non-fat, which is the main source of protein, and this it actually gives it its chewness for it. We have also the sugars and the sweeteners. These sugars, they act as a bulking agent, and they act also as binding or binders for water, and also it gives it a sweet taste. We have also the stabilizers. These that stabilizes the overall structure of the ice cream and the hear me? Hello?
Yes, we can
Hello,
hear
can
you.
you hear me? Okay.
Yes.
We have also the flavors and the coloring agents that are added to the ice cream. And now let's get to on how the ice cream is being made in general and any manufacturer. We have here first all these ingredients are mixed together, then they are homogenized, then they pass through a PHE or this is a plate heat exchanger, and then they pass through a stage of aging to form at the end a product with a 10% fat, and this is not the final product, but this is a between product which has 10% fat and 90% sugar solution. And then we have the next steps include the freezing and the filling and then the hardening, and then we have a final product that can be delivered to the consumer. So this is the basic steps of making an ice cream. Now we have our idea or our innovative idea, which is to make a fortified ice cream with a rich source of fiber like the Sesame Hull. We have here, you may think that here, this is the same picture as the one you may think that here this is the same picture as the one we discussed previously, but we have another ingredient, this is the main difference, which is added, which is the Sesame Hull, and this is considered, like my colleague said, that this is the food waste or a major food waste of the tahini production. And now we made several trials to make different ice cream recipes by substituting the first one we have T1, the first one, this is a normal ice cream recipe without substituting any of it with the Sesame Hull. The second one we substituted with the 25% of concentration of Sesame Hull. And then the third one we substituted by 30%. And then the fourth one we substituted by 35%. We substituted mainly the whole milk powder with the Sesame Hull, the waste. And now, why do consumers will be attracted to this certain product in general? Well, of course, because of its health, that can encourage them. Well, this would be a good treat, and also it would be a fiber-rich product that can make you feel more full, and also it can control your diabetes and your cholesterol level. And other benefits, they include that it prevents the constipation, the diverticulosis disorder, and it can help in cases people who suffer from diarrhea and IBS, and also can treat the hemorrhoids and the heart ailment and prevent the cancer. So these were the expected health benefits that we thought about when we were making this product. And now also this also can make you, other than it can make you feel full, or as a result of that, you will be aided in weight loss for people who suffer from that. And now let's get to Mohammed.
Okay, here I am again. So most of us are familiar with ice cream with different kinds of flavors such as chocolate, caramel, vanilla, and also using so many different recipes. But we are all ignoring the nutritional value or the nutritional sources that we can use to enrich our ice cream. So this is the main idea of our product, is to use a food waste which is so much in the market, and they obtain it with huge amounts, and they either use it as animal feed or they burn it to lose it, to get rid of it. So our main idea is to, as you know, to produce the high value ice cream and to be with low cost. And here's our conclusion. Our conclusion in the last, we obtained, we did a sensory evaluation of our ice cream, and the people opinion were so good about it, so it doesn't change in taste, but we are waiting for the chemical tests and the physical tests. That's all I think. So I hope you like our idea.
Great. Thank you.
And
Thank you very much to the Food Savers team. I think we have time for 2 questions, so we try and keep to the time of our agenda. Are there questions from the audience? Again, you can raise your hand, you can type a question, or you can open your own microphone.
I have one question regarding the choice of ice cream. I think you could find other products that I don't know how ice cream are consumed in your country, but is it really a significant product in terms of consumption? Why did you not choose another usual product to valorize Sesame Hull? Why you decided to choose this ice cream? And yes, okay.
okay. Okay, first of all, we intended to use the Sesame Hull in substitute it with another product such as bread, but we estimated that it will impact on the color of the bread. So going to the ice cream, it won't impact in the color, and also it will be good for children. Children like ice cream very much, and it's a very, very important product for them, and also for adults. So we focused on the ice cream to be a good source of vitamins and nutrition for the children.
And also in the Middle East, can I just continue? In the Middle East, we have a huge production of the tahini. So we thought about on the waste. Why not use this waste? And also a huge production of the ice cream. So why not mix it together?
May I make a question?
Okay, thank you.
Yes, Christina.
Hi,
Yes.
hello. It's for me a pleasure also to share to be today, because to share with the Paola and Gerard, because this group is here today because I was in Cairo and announced this competition, and I'm very happy that you also representing your institution were able to be here today, and also with the good proposal. Yeah, so I think I'm glad to see that you make a proposal that you already tried, at least to see if the product is acceptable. You did not mention, but I think maybe also the added value, I mean the profit from the byproduct, maybe it could be higher in ice cream than in bread. I don't know. Bread normally is perceived as lower cost, is even government's finance lower cost for poor people. Do you think how do you think you are going to promote your product? Will you say that it has had some byproduct that nobody wanted it, or you will try to not to say this and promote the good functional properties and even sell it at higher price than normal ice cream?
Okay, no, it was claimed that we used Sesame Hull, but in the sensory evaluation, we didn't tell people before they taste it. They gave them 2 samples, the reference one, which is normal ice cream, and the other sample was our sample. So we asked them to give us their opinion about the difference between both samples. Most people didn't find any changes in the taste or the color or anything. So it was a very good point that they didn't notice any changes. But after that, we told them that we are using Sesame Hull as a functional ingredient, and they were so amazed that we used something like that and didn't impact anything on the product.
So you also did not notice any difficulty in terms of production of the texture of the ice cream. It behaves the same way as the normal one in the production, at least at the pilot scale. I'm asking. Maybe I was not clear with the question. I mean, in the production, if it was the mixture you prepared with the byproduct, if it behaved in the same way. I think they are frozen. Oh, are you listening me? Yeah, they are frozen.
I think they are frozen.
Yeah.
Yeah, we can't hear them
I
anymore.
was repeating the question, but
I will
anyway,
just read. There is one comment from the audience typed in, and the comment is that it would be nice to see a photo of the ice cream to also see what the appearance of it is.
Yeah.
So
Good.
that is a comment from the attendees. Okay, so I guess we will move to the next. We did get some good questions and answers, and thank you very much to the Food Savers team. And our next presentation is from the team FIP AIDS. And this team is presenting a project called Spent Grain Fiber. And leading that presentation is Janelle. And Janelle, I will make you the presenter now. So Janelle, you can turn on your webcam. And Yusra, can you turn your webcam off? Yeah, great. Okay, Janelle, I think we are ready for you.
We're very sorry. Hi, can you hear me okay?
Yes, just fine.
Hi, I'm Janelle Myers, and I'm presenting our project Spent Grain Fiber Recovery. So we are 4 students. We're all master's students in the Food Innovation and Product Design master's program at Agri Tech. So our team name is FIPADES because our program is called FIPDES, and we kind of inserted IPA into it. So that's where that comes from. And I'm just going to tell you some more about our project. So we're proposing the creation of a company called Malta. So Malta is the Spanish translation of malt, which is the main product or main ingredient in brewing beer. And we're proposing extracting dietary fiber from brewer spent grain, and in that way bridging the gap between food waste and people's health. So using a sustainable process to valorize waste and also improve the health of consumers. So there are a number of objectives of the company, mostly based around sustainability. So this would be using a waste product of the beer industry and turning it into a value-added product for consumers. And we would be turning that into something that we would sell to other food manufacturers for use in their products. So I have to thank the other presenters. They've already done a good job of covering the background for us, both on the brewer spent grain side as well as the fiber side, but I'll give you a little bit more information here. So as the first team explained, brewer spent grain is the byproduct of making beer. It's the malt that is left over, the insoluble parts of it. And as he said, worldwide beer production is about 2 billion hectoliters. So given that there's 20 kilograms of brewer spent grain produced for every 100 liters, that leads to a worldwide production of 40 million tons annually of brewer spent grain. So currently, as he explained, this goes often to animal feed. It's used in small amounts in making other food products like crackers or breads. But the usage rate in those kind of products is very limited. It's also sometimes used for biogas, but we believe that this can go to a higher value product and actually be turned into human food because there is wasted nutrition when we use it for other purposes. So given that brewer spent grain is about 70% fiber by dry weight, we decided to look at the fiber market and see if there was an opportunity there for this kind of product. So we're basing this in the US because of it accounts for about 40% of the fiber market. And it's currently, the market there is currently over $3 billion, and it is growing every year. So currently, about 40% of American consumers are looking to increase their fiber, and dietary trends point to the importance of gut health and especially of increasing fiber. So as our second team explained, there are a number of health benefits of fiber, including lowering LDL cholesterol and blood glucose. And especially the fiber that we're targeting is an arabinoxalan, which is an insoluble dietary fiber. So rather than some of the more common fibers like inulin or chicory root, which are soluble, this passes through to the colon and is fermented by bacteria in the colon. So this produces short-chain fatty acids that have a number of specific health benefits, even beyond what you see from fibers like inulin. So the goal of our product would be to combine this issue and the opportunity that we see. So we would collect the spent grain from breweries, extract the purified arabinoxalans, and then sell it to other food manufacturers for use in their products. So fibers are used in all sorts of products, and that would be up to the secondary manufacturers, our customers. But large markets for it include in bars, in breads, and other baked goods, both for shelf life extension and also for fiber claims in products for consumers. So I'm going to tell you a little bit more about the process that we're proposing. This is based on some pretty new and exciting research coming out of Portugal. They have, the team in Portugal has proven that this works, this extraction process works on a lab scale. And so what we're proposing is to scale it up to an industrial scale and be able to solve the problem on the level that it's at. So the first step would be receiving the material from the breweries. And as the first team explained, there is significant microbial risk here. The shelf life of the product when wet is not very long. And so we would locate the production facility in a place with a lot of breweries so that we would shorten the transportation time and be able to work with breweries on their schedule in order to minimize the microbial risk. For this, we've targeted Chicago because it has a large number of breweries, including larger scale breweries that would be able to provide the raw material on a large scale for us. So after receiving the material, the spent grain undergoes a 4-step wash process. So first being washed with potassium hydroxide to remove the lipids, then 2 acid washes, citric acid and hydrochloric acid, will remove the proteins, and a final step washing with ethanol will remove or will separate the arabinoxalans. And from there it goes into drying and then packaging. So like I said, this is based on research that has been done at small scale. So a big hurdle for us would be the scale-up process. We believe that we can use equipment that is currently in production and currently in use in the starch industry, which would allow us to not have to custom design equipment, but use something that's already available. But obviously that scale-up process would be work that we would need to test. One more note on the process, in addition to focusing on sustainability with the use of waste products, it's actually possible to reuse the solvents in the process, apart from potassium hydroxide. So the acids and the ethanol would be able to be recycled and reused in the process, which would reduce the waste produced by the processing step itself. So as we've talked about today, it's very important that we focus on sustainability and have these values for our customers, but it's also important that we make this work financially. So as we're looking at the financial side of this, you can buy spent grain in the US for about $33 per ton. So that is what farmers are paying to feed it to their animals. And given that price and about a 20% yield from the process, we are still able to reach a profit because you can sell the fiber for about $1,500 per ton. So we see this huge value add between buying the spent grain at $33 per ton and selling it at $1,500 per ton. This gives us a cost of sales around 15%. And this is just for the processing step. We did some other calculations adding in equipment costs and salaries for people, and we still end up with a gross margin estimated around 40%. So we see a lot of promise here, and we think that we'd be able to compete with other fibers that are currently on the market, in addition to offering the sustainability story for the manufacturers and consumers. So in conclusion, we're looking to turn what's currently a waste product or being used for lower value purposes into something that would be used for human food and also be able to provide some additional nutrition to people. There's very stable supply and demand as the world beer production is high and not decreasing anytime soon. And we also see, as was pointed out previously, an increasing demand for sustainable products. So people are looking for this kind of story and are willing, in some cases, to pay more for this kind of story. And therefore, we do think that we could draw on that trend and see some success there. And as I briefly pointed out with the finances, in addition to having this story, we actually do see that we would be able to be profitable in probably about year 3. So thank you very much for your time.
Great, thank you, Janelle. Thanks very much for a very interesting presentation. And we can open now to take 2 questions, I think. We have enough time. So again, you can type your question, you can raise your hand, you can open your own microphone. Gerhard.
A very nice presentation and also a very interesting idea of this process. I also liked that you did the calculation of the costs and so on, and to see what are the benefits out of this. Did you also consider some quality aspects of the product itself for quality assurance? For example, are there any risks of the product, or how you could measure the quality in terms of purity or concentration of the extract?
Thank you for the question. I think that we would have to do definitely quality assurance testing on the product as it came in. I think the biggest risk for us in terms of safety is the microbial risk of the original product. So that would require working with the breweries on logistics and making sure that we have strict controls in place around temperature and time to ensure that there isn't any dangerous microbial growth happening at the beginning. And then in terms of quality assurance at the end, so we're basing this on research that has really been done. So we know that the process works, and in their findings, they found that the quality of the arabinoxylane extracted was up to the standards that they see in the fiber market right now. And so we believe that we'd be able to match what is currently available.
Okay, thank you.
Just 2 more small questions. One is related to the previous one. I mean, is there any risk of residues of pesticides or whatever it is from the production? And secondly, if you know something about the potential impact on microbial growth, so to evaluate, because some of these are can also, there are some polysaccharides with functionality. If there is any study on this, obviously it's just a general question.
Yeah, so with respect to the pesticides, we're using malt that has already been used in the brewing industry. So from that from that perspective, we don't anticipate any residues from pesticides because this would already be validated and is being used in brewing. And the solvents, the process has been designed to remove any traces of solvent during the process as well. And I'm sorry, could you repeat the second part of your question?
If you have any information about the potential, let's say, technological functionalities in terms of antimicrobial activity or antioxidant, because sometimes these ingredients, I mean, the single components may have additional functionalities than simple as a
That's very interesting. At this point, we've mostly focused on the health and digestive benefits of arabinoxolans, but it would definitely be worth looking into some of the other benefits as well. I think I know that they have anti-inflammatory properties in the body, so it's possible that they have some other functional benefits that we would be able to talk about as well with respect to the product.
Thank you.
A comment from one of the attendees. And the comment is, I would like to ask how the rest of the spent grain will be utilized apart from the extracted component.
That's a very good question, and something that would be something we need to deal with as part of the scale-up process. One very large component of the weight of the spent grain is water. So simply by drying it, we'd be kind of dealing with a lot of the weight of the product. In addition, so 70% of the dry weight of the spent grain is fiber. There's an additional, I believe about 20% that's protein. So there's further research that's being undergone right now to look at extracting the proteins as well. So that could be a future use to get even more value out of the product and reduce the waste streams that we would be creating as well.
Great, thank you.
Thanks very much.
Okay, so our next presentation is from the team Food Resolver, and the title of their project is Food Wastage Control and Management. But I must add that I don't see anyone from the team Food Resolver in the conference. So if someone is here, Isha or Simran or Savrit, please, can you identify yourself, because I don't see any of your names in the attendees. And I don't see anyone responding, so I'm going to move to the next presentation, and if someone from the team comes, we will just change the order. So moving to the next and potentially final presentation, it is the team Food Artisans, and their project is called To Utilize and Convert Cereals and Vegetable Waste into Dry Matter for Producing Sustainable Energy. And here we have presenting Pragnash Mishra, and I will make you presenter now, Pragnash. There you go. Please, can you turn on your webcam? And also your microphone is muted. Pragnash, can you unmute your microphone? Great. I see that you are unmuted, but I don't hear you yet. Mm-hmm. Okay, good. Hi. Great.
So we are food artisans, and the project title is to utilize for cereals and
share your screen so that we can see your slides.
Can you see that?
No, I see you, but not your slides.
Now can you see that?
No. You have a button called sharing, and you go to that and you go share screen.
Now can you see that?
No. I see the connection is not really very good. I'm going to turn my webcam off, try and get the bandwidth for you. And maybe you turn off your webcam also and just share your screen.
Maybe if it does not work, you could open the presentation maybe, and you could speak to that.
Mm-hmm.
I'll start with my presentation. So we are food artisans, and our project title is to utilize and convert cereals and vegetable waste into dry matter for producing sustainable energy. The aim of this study is to utilize the waste of cereals and vegetables to prepare a dry matter which can help in energy generation for food industries. The previous data shows that 95 million tons of cereals and 80 million tons of vegetables are wasted worldwide in a year. All these waste contains vast amount of utilizable properties such as food fiber, calorific values, and the fuel, etc. With such a huge amount of waste, there comes a potential opportunity for food technologists to prepare and optimize methodologies. Because these energy can be converted into a greater form for the food industries. Here, our aim is to convert the semi-dry matter into dry matter from which the energy can be generated. The objectives are, first of all, we have to prepare the charts for the cereals and vegetable waste around the world, which can help us in concluding the particulars of cereals and vegetables, which can be utilized for energy generation. Then the second objective is we have to prepare the data, we have to prepare the analysis, we have to prepare all the problems, and then analyze those and get some solution for that. All the methodologies and the process used for the conversion of cereals and vegetable solid waste into solid waste, we have to get the detailed information and we have to start looking for the conversion process in a more efficient way. Our project is divided into 3 parts. First part is project formulation, the second part is project development, and the third part is project implementation. In the project formulation, it is divided into 5 steps. First step is the problem statement. All the problem statements which the industries are facing, we have to collect those. Then we have to collect all the data which the industries provide. Then we have to analyze that data there with 2 approaches, theoretical and practical. Then we have to prepare the objectives based on the problem statement of the industry. Then we have to develop the project. Formulation, like it is written, first of all, problem statement, the industry collection, all the data for the methodologies and the process which can be applied, analysis, theoretical and practical approaches for solving the issues needed for proper information, understanding of information gathered, then the preparation of objective, and then the project development. Now, the project development, the first step is whatever the data we have gathered from the project and formulation, that data needs to be then or needs to be implemented in a very small form. Then the second step is we have to prepare a prototype for that. Now, after the prototype has been created, then we have to collect all the raw materials from those industries. We have to mash each other. We have to start looking for the drying techniques, all the drying techniques which can be implemented for the drying. Then we have to form them into pellets, the small square pellets or cubes. Then we have to look for how we can calculate the energies through various techniques. Now we have to convert the energy, and whatever the energy is formed from the dried food waste, then we have to represent those data in the form of tables or graphs or charts. Now, as we can see that project development stages with description, there are 7 stages. The most important stages are drying through various drying techniques. There are different time and temperature combinations which need to be taken care of. So with 2 techniques like traditional techniques and advanced techniques, we can look for which drying technique is best for the energy conversion. First, the traditional technique, conduction, convection, and radiation. Then the second, advanced technique, ohmic heating, pulse heating, and high pressure processing. We can look for a better option in all those 6 types of drying. Then we have to form them into pellets. Unlike in bomb colorimeter, we form the pellets and then we calculate the energy. Like that only we have to form those pellets. After that, we can go for the energy calculation. Now the energy can be calculated on various methods. Like there are different types of energy: ingested energy, digestible energy, metabolizable energy, and net energy for maintenance. All these energy are necessary, which these all energies will give us an idea of how much energy is created from the dried matters. So in ingested energy, we can calculate fecal energy, combustible energy, digestible energy, urinary energy, and surface energy. Net energy, net obligatory dietary thermogenesis, and the thermogenesis due to cold, drugs, and hormones, etc. Now we can also we can also calculate the net energy for maintenance, like basal metabolism and physical activity of the microorganism in that. Now, what I'm going to talk about is the anaerobic digestion process, a digestion process in the absence of air. First of all, we have a substrate which contains carbohydrates, proteins, fats. After the hydrolysis of the substrate, we obtain sugar, amino acids, fatty acids, which are also called soluble organic compounds. After the soluble organic compounds are obtained, we go for the acidogenesis. Acidogenesis, formation of acids. Now, after the formation of acid is done, we come here with the alcohols, carbonic acids, and volatile fatty acids. After the acid formation, acetogenesis is carried on. In acetogenesis, acetic acid is formed. After the acetic acid formation takes place, we go for the methanogenesis. In methanogenesis, methane is formed. Methane is a type of gas which can be used for like goba gas and other greener type of fuels which can help in reduction of exploitation of the natural resources. Now after the methanogenesis is carried, we obtain biogas. These all the substrates, soluble organic compounds, acid formation, acetic acid formation, and the biogas comes under the anaerobic digestion process. These anaerobic digestion process can be implemented in a small area and a large area, and these are not very costly, and it can be planted with a small amount of capital. Now these data shows that worldwide generation of food waste in developed and developing country. We can see that In United States, it's around 61 million tons per year, and in developing countries for China, 200 million tons per year of the food is wasted in a year. Now, the second graph shows that the bioenergy potential from food in developed and developing countries. Like in China, we can see that the energy or bioenergy potential is very high. It is about 160,000 GWH per year, and in United States, it's around 500 GWH per year. Now, the third graph shows that per capita food waste generation in developed and developing countries. We can see that Canada produces the highest amount of per capita food, which is around 0.5 kg per day. And the second part shows that Brazil and India produces 0.2 kg per day of per capita food waste. Now, the typical wasted food in the world. We can see that cereals and vegetables are on the highest wasted food in the world. Like unlike cereals, it is around 90,000 million tons, and for vegetables around 80,000 million tons, which gives us opportunity to convert the energy from the dried waste for a better use in the industries. These graphs show that it is a very potential product. This idea can be implemented and can be used for the betterment of industries, and also helps in the food security and to produce and maintain a very greener environment. Thanks.
Okay. Thank you. Thank you, Pragnesh, very much for an interesting presentation. And we can take a couple of questions, please, from the audience.
Yeah, I have one question. Just a moment, I'm here. In one of your slides, you mentioned that you can use innovative technologies to dry the materials, like high pressure. I wonder, maybe I lost some last papers or innovation by the use of high pressure, but I don't see any application in this respect. So just let me know if you know specific application in this area.
Ma'am, we don't know about the specific application in this area, but we can look for a possibility of high pressure processing in the drying technique of the dried products of the waste of cereals and vegetables. Because this is just an idea, so we thought to add, and then in the further process we can look for all the possible applications and all the possible opportunities, and if high pressure processing can be applied to our product or not.
Yeah, I mean, for sure high pressure can be used in this complex system, but in my opinion, not for drying. It's really, I mean, the concept and the equipment do not allow any water evaporation.
Okay, we will look after that. We will remove this high pressure processing, and we will try to add some other technique which can be used for the drying.
Is there anything else from the audience or the scientific board? Gerhard, are you?
Sorry,
It's okay.
my microphone. So yeah, interesting concept. Just wondering also about the drying techniques. You have different types of waste materials with different type of water content or moisture. So did you make some considerations about which technique would be feasible for which kind of waste material, or this is just a general brainstorming?
Yes, sir. We will consider some dry waste around possible moisture content. We will try to take around 15 to 20% moisture content, and the food waste which contains a bit more than that, we can use the techniques which are suitable for them.
I missed somehow, maybe I missed it in the presentation somehow, solar drying or something like this. Could that be also applied or a possibility to be implemented?
Yeah, it can be implemented, but it's a very slow process. It will take a lot of time. So we can act in the future if the possibilities are there.
Okay, thank you.
Okay. If there's no other question, then I make a final call to the Food Resolver team. I still don't see any of the team members in the webinar, and I don't have any response from them by email. So I think we will have to close the presentations now. And I ask everyone please to stay connected, and we will take a short break, I hope 10 minutes in the maximum, while the scientific board is completing their evaluation and we can make the final tally of the points. So please don't leave the meeting. And to the scientific board, I think the best way is to put your final evaluations in the Dropbox. And then I made a final form where I put everyone's together, and we can just add the presentation there, and we should have the tally automatically.
Okay, mine is saved in the Dropbox.
Okay.
Soon also mine. So 10 minutes and we will be back here.
Okay. Okay. Christina and
also mine. I was not aware that I had the sound off.
Okay.
Yeah. Okay. I have the continuation of the presentation of before with the last the announcement of the third, second, and first. So as soon as we have this, I will update it.
Okay. So shall I be the one who I will tally the different points?
Yes, I mean, I can, also the presentation is uploaded in the Dropbox. You can also make you by yourself the announcement on our behalf. I mean, I just
make the announcement of the winning team.
Yeah, or I can do, or Christine. I mean, it's up.
Oh, that's however you like. I want to be sure I have all of the points. So Gerhard,
the points, the mine I have there. I don't know, Christoph.
Yeah, I don't know. Haven't heard from him now in a few minutes. Okay, so I'm going to put the.
Yes,
I
I'm here. Well, I didn't understand the process. So now I have to open my table Excel file and to fill it. That's true or not?
The last two columns.
Yes, the last two columns. Okay. But we do not discuss together about.
Yes, but at first let's see the final scores, and I mean.
Okay.
Because we are working independently at first, and then we have to discuss, obviously.
I just remind you that all of the participants can hear us.
Yeah.
Just so maybe you want to maybe make a Skype.
No, but we have to close the
No.
I mean, for the
while discussing, we have to close, no?
Yeah.
If we close it, then how do they come back?
No.
And they tell them all to come back?
We cannot make them. We cannot make them attendees.
Can do by Skype.
Yeah, I can make them attendees, but I think they still can hear us because the
Maybe you can put the sound off here, and we do by Skype.
That's what Lena and I did.
We move on Skype.
Right.
But we are missing Christoph. I don't know if Christoph is on Skype.
Yes. You hear me?
Yes.
Oh, I have to mute. No?
Yeah.
Oh, here's your Skype nickname, Christoph.
It's Christophe Cotillon.
Okay.
No. Skype is Actia/Cotillon, I think. I don't remember exactly. I can check.
Cotillon, okay, I found it.
Actia.
Yeah. Okay.
So you make the call, Paola?
Yes, I try to do it. But you have to accept my invitation at first, otherwise. I'm calling you.
Hello?
Here we are.
Okay.
You should mute your microphone on the group meeting, otherwise all can hear us. Also,
Okay, so we are back. I'm glad to see that the attendees and the presenters are all still in the conference. And after a deliberation, we have come to the conclusion on the winning teams. And I will turn over to Paola to show her final few slides and announce the winners. So Paola, let me make you the presenter.
Yes, thank you.
Okay.
So now is my time again. So let's move to the presentation mode. It takes some time. Okay, here we were at the beginning. Actually, 5 teams submitted the report and the presentation, and they were evaluated until this morning. Unfortunately, one team, the food resolver, didn't show up. We enjoyed all of the presentation from the Cyclos, Food Savers, FooD-STA, and the food artisans. And then we made independent evaluations. And at the end, now we came out with a ranking of the projects and the presentation. First, before I start giving the ranking that obviously will be focused on the third, second, and first position, I would like to thank you all. Because actually you tried to contribute somehow to your to the improvement of your skills. You showed us really interesting projects. We were also discussing during the break while putting some figures in our tables, and we really hope that your projects will be exploited in the near future. So all of us as consumers can also benefit. So let's go now to announce the winner of the third position, and I would like to announce it with the next slide, like it follows. And the third position, we have FooD-STA team with this really interesting project on the recovery of a precious ingredient from the spent beer. And the award that the sponsor, the ISEKI-Food Association, has decided, defined, is €100. Then now we move to the second position, and we are very pleased to announce that in the second position we have Cyclos. Again, recovery of waste from the beer production. Really interesting project. And we hope that also in this case, in the near future, we could drink maybe some beer in in glasses made of bioplastics, made with the recovery of the beer spent grain. And now last, oh sorry, I was forgetting, the award, the team will be awarded of €150. And then last but not least, actually the first position is given to the food savers. The ISEKI-Food Association is pleased to award the first team with €250, and then also to give to one member of the team a free registration at the 6th ISEKI-Food Conference, which is the international conference promoted by the ISEKI-Food Association, to present in this case also the poster of the project. The ISEKI-Food Association 6th edition will take place in Nicosia, Cyprus, 8 to 10 July 2020. And actually, the main theme of the conference is Sustainable Development Goals in the Food System, Challenges and Opportunities for the Future. And we are very pleased to invite the team, but all the teams that were participating to the Food-Factory-4-Us 2019 edition to submit abstracts related to their project. So here again, FooD-STA, our compliments for your really interesting project, and we really hope that maybe this can be effectively exploited in real food products. So for this, I think that from my side, I would like to thank again all of you, all the teams, all the scientific members, and now I give also the floor to them to make also some comments and wishes to all. But from our side, for all, on behalf of all the members of the scientific and organizing committee of the Food-Factory-4-Us 2019, thank you very much. And obviously we launch already the fourth edition 2020 that will be launched this autumn as always, and so start to disseminate also this information to your colleagues, so maybe they could have also additional and further opportunities to participate. I would like to wish you all the best for your future career, and I really hope to see you soon. So now I give the floor again to Catherine, Gerard, Christina, and Christopher for the last words. Thank you very much, and see you soon.
Okay, the floor is open for the scientific board to say thank you and goodbye. I will say mine. It was a pleasure. Exciting projects and really excellent presentations. And I look forward to seeing the winning team in Cyprus in July of next year.
So thank you for my part. I'm Christophe Cotillon. I was very happy to be involved in this competition, and I congratulate all the winning. You were very nice, and you made a very good job, good presentation. So I want to congratulate you and wish you a very nice future in your research activities.
So, Catherine, I don't know if you can open the video for at least the winners. I don't know. It would be nice that we take a picture with them.
Yes, yes,
at least
yes.
last edition we did. We would like to see the faces of the winners. We of course we wish they are happy, and I'm especially.
Yeah, I see also the comments from Irineos, which is the second winners.
Yes.
Thank you very much also from, I think that you did a very good job, and we did also as independent evaluators a good job.
So I think it would be nice to open the camera for them to say goodbye, yes, to all of them. Yes, to all of them. I think it's the webinar supports.
There we go.
Yeah.
Okay.
Yes.
Thank you. Thank you.
Good. Thank you. And
It was our pleasure to be a part of your competition.
yeah, good. So I give my regards to your professors, and let's work together for you to try to come to our conference. I think it will be an excellent opportunity, at least for one of you. But we have to find the financing for coming. But at least when you arrive, the registration is offered from IFA. So thank you very much. Also to all of you. Of course, we could not give the first prize to all, so we had to decide. Yeah.
Thank you.
Thank you very much.
Thank you.
Thank you also from my side. I appreciate very much the ideas and your engagement in this project. Congratulations. And hopefully something will be successful.
Good.
So,
Okay. Bye, everyone.
Bye.
thank you very much.
Bye.
See you soon.
Bye-bye. Bye-bye.
See you
Bye.
soon.
Bye-bye.
We can't wait to see you again.